In question 24, we've got this function that satisfies this equation for all x except when x is 0 or 1. And we're required to find f of 3. So the least we can do is to plug in x equals 3 and see what happens. Now, the more equations we have that involve f of 3, the better. We could get another one by plugging in a number to make 1 over 1 minus x equal to 3. And you can do that by plugging in x equals 2/3. Because then 1 minus x will be 1/3, and the reciprocal of 1/3 is 3. So let's do that. We plug in x equals 2/3. And at this point, you might think you're a bit stuck, but have a dream, okay? Wouldn't it be nice if we could get a third equation? Maybe, you know, one relating f of minus a half and f of plus 2/3. Because then we'd have 3 equations and 3 unknowns that we could solve. So let's just hope, try plugging in x is minus a half. Now, if I plug in x is minus a half here, that becomes 1 over 3 over 2. It becomes 2/3. And we had plugged in x is minus a half, and so this here is minus 12. Well, we seem to have got very lucky there. Nonetheless, if we regard these as unknowns, we've got 3 linear equations and 3 unknowns, and we ought to be able to solve them. And so we could go ahead and solve 3 linear equations and 3 unknowns in the usual way. But you could do that more quickly than using a standard method. You could just add up the left-hand sides of the first 2 equations and subtract the third left-hand side, because that would leave you with twice what you're interested in. On the other hand, if you add up 72 to 16, you get 88, and you subtract minus 12, you get 100. From which it follows that f of 3 is 50. So now I want to give an explanation of why it is that we got so lucky in that question. Encoded within it was this function g. G of x is 1 over 1 minus x. It's a perfectly good recipe for a function, except that it doesn't work when x is 1. So we will ban x from being 1. But I want to compose this function with itself. So I must be very careful about what values it takes. It doesn't take the value 1. It doesn't take the value 0 either. So I'm going to somehow also insist that x is not 0. Now, if you calculate g applied to x, you get something, and I invite you to do that. If you calculate g applied to g applied to g applied to x, something wonderful happens. It does nothing at all. It gets you back where you started with. So, when we look at our original problem, cast it in this language, the equation we were given was that f of x plus f of g of x was equal to, well, in this case, 24x. Now replace x by g of x in this equation. We obtain f of g of x plus f of g of x equals 24 g of x. Finally, take the first equation and replace x by g of x. And what we've got here is f of g of x, so that's just f of x. Now you can find a formula for f of x by adding up the top and the bottom equation and subtracting the middle one. And all the g's that occur anywhere on the left-hand side will all vanish, and you'll be left with twice f of x. On the right-hand side, you have to add up the first and the last term and subtract the second. And divide by 2, f of x is 12 times that formula. But you know what g of x is, so you've done it. It doesn't matter what the function g of x is, as long as it's got the property that if you compose it with itself 3 times and it avoids these bad values, the same argument will work. We have this formula for f of x in terms of the function g of x. You know what g of x is, so you can work out all the details and get an explicit formula for f of x. And there it is, the function that was causing all the trouble in the first place. And if you evaluate at 3, you get 12 times 1 plus 3 plus a sixth. And that, I hope, gives 50.